Okay, welcome to video 6. Today we're going to be talking about solving quadratic and linear systems, and it's just like solving systems like we've already done in the past. So recall when you have two or more equations, you have a system, and we've already done this with linear functions, having two lines graphed and solved algebraically. In this lesson, we will specifically be looking at a system made of a quadratic equation, which has a degree of 2, and a linear function with a degree of 1. So the solution to a system are always written as x comma y coordinates, and in the past they've been 1 point, but now that we're talking about quadratics, it can be more than 1. So determine the solutions to the systems graphed below. As we can see here, these are the three opportunities we have when we have quadratics and lines. They might not touch at all, they might touch in one place, or they might cross in two places. So those are the solutions, where they intersect. So in this first one, since they do not intersect at all, we're going to say that this one has no solutions. Because although they go on forever, this one is never going to cross the parabola. In this one, we have one point of intersection, and we can see from the graph that it's right 2, down 6. So my solution is 2, negative 6. And remember that since that's a point, we write it as x comma y in parentheses to indicate that it's a point. And in the next one, it crosses in two places, right here at negative 2, or negative 3, 0, and here at 5, 8. And again, those are written as points because they have x comma y coordinates as to where they cross. So remember, when we solve the systems, whether it's graphically or algebraically, we will always have these three opportunities. Either they'll cross in one place, two places, or not at all. Okay, so let's look at an example here. Solve a system, a quadratic and a linear function. So to solve the quadratic, we need to first graph it, which means I need to start with the axis of symmetry. Okay, so I have a lot of work here that I just wrote out, and we're going to go through it all. Axis of symmetry formula is the negative b over 2a, as we've already been using. Then I wrote down a and b. I didn't bother writing c. It is negative 3, but I don't need it because I'm not solving for the roots, so there's no real reason to write it down. But you can. It doesn't hurt. Then we have x equals negative 4 divided by 2 times negative 1, which is negative 4 divided by negative 2, which comes out to be 2. Now, what's the whole point of doing that? So that we know that this number needs to be put in the middle of our table. And then we need 3 numbers above and 3 numbers below. So count back 3 for 1, 0, negative 1, and up 3 for 3, 4, 5. That tells me that these are the x coordinates that I need to graph in order to see the U shape for this parabola. So then I'm going to go ahead to y equals, plug in negative x squared plus 4x minus 3, then hit second graph so I can look at the table and get these y values out of the calculator. And if we have done this correctly, we should see the repeating y values on either side of our turning point, which is where the axis of symmetry goes through. And I can see that here. It does go negative 8, negative 3, 0, 1, then back to 0, negative 3, negative 8. So now we could go ahead and plot those and connect with a smooth curve. So you can see, and you can probably make yours look a little bit nicer. It's kind of hard on the iPad, but I've plotted those nice points and then connected with a line. And then what we've already learned how to do a long time ago is to graph this x plus y equals 1. We have to put it in y equals. So I'm going to subtract the x from both sides. So when I do that, I get y equals negative x plus 1, which tells me that my slope is going to be negative 1 over 1, and my b value is 1. So I'm going to start by plotting that b value up 1, and then use my slope to continue to plot other points by going down 1, right 1. Okay, so again, you could probably do a little bit better than I did, but now I have those, the line and the quadratic plotted on there, but I'm missing one very key thing, which is a label on each. Since I'm plotting two things, I absolutely must have my labels. So I've got x plus y equals 1, and the y equals x squared plus 4x minus 3. So now I've done all this lovely work, but I still have not answered my question yet, which is to find the solution. So I have 2 points where they intersect, so I just need to write solutions and the coordinates for where they cross. And those are my answers. Now you can check in your graphing calculator by finding the intersection. So to do that, once you have your two equations in y equals, you're going to go to second trace so that we calculate, And then pick number 5, which is the intersection. Move the cursor to the wanted intersection point so that you're close to it, and then hit enter 3 times, and you can check your answer that way. Okay, so for this next question, we again have a parabola, y equals x squared plus 4x plus 4, and then we have a line, y equals negative 2x plus 4. So let's start with the parabola. In order to graph the parabola, we need to start by finding the axis of symmetry. So the formula is x equals negative b over 2a. In order to fill this in, I have to identify the a and b value. Again, since I know all I'm finding is the axis of symmetry, I'm not going to bother writing down what the c value is. So then I can fill in those values, 1 and 4, that I wrote above, a equals 1, b equals 4, into my formula. So then it becomes x equals negative 4 over 2 times 1. Again, depending on your calculator, you can either put that in as a fraction right away so that you can get out the axis of symmetry as an answer, or simplify the numerator, simplify the denominator, and then divide at the end. Give that a try, and let's see if you get the same answer as I do. My answer was x equals negative 2. So the whole point of doing this is so that I know that in the middle of my table, I need a value of negative 2. So in the middle, I'm going to put negative 2. So then once I put the negative 2 in the middle, I just go back 3 and then up 3. So back would be negative 3, negative 4, negative 5, and then up 3, negative 1, 0, and 1. Now that I found the x values, I need to get the y values by going to my calculator. So in your calculator, press the y equals button. Then plug in x squared plus 4x plus 4. Second graph will get you to the table of values, and then hopefully you'll find the values that match mine. When we do that, I get the values 9, 4, 1, 0, 1, 4, and 9. And I like this because I can see that on either side of my turning point I have in the middle, I see the symmetry of the same number on each side. So that tells me I'm probably at the right part of my graph. If I didn't have this symmetry on both sides of my table, I would look back at the axis of symmetry to see if I made an error in there. Maybe I lost a negative or something like that, and then go try to figure out the correct part of the table. You can scroll through the table to try to see where those values go down and then back up again for this parabola. Now that I have these points, I can go ahead and graph them on my graph. Okay, so you might need to pause the video and just go ahead and plot those points. So we go x value, so negative 5 up to 9, and then negative 4 up to 4, negative 3 up to 1, negative 2, 0, negative 1, 1, 0, 4, and then 1 up to 9. Now that I have all those points, we connect with a smooth curve. Okay, so hopefully your graph looks something like mine. Now for the next one, we need to graph y equals negative 2x plus 4, the other graph. So this is a line. I need to start by either identifying the slope and the y-intercept and then using those to plot other points on the graph, or you can just put this in y equals also. So go back to y equals, and then you'll put in negative 2x plus 4. If you do that way, then you should have another table of values that shows the x and y values that you plotted from the graph. I'm going to use the slope and y-intercept. So I'm going to identify slope and y-intercept. So I just wrote down m equals negative 2 over 1 and b equals 4. So that means that I need to start at the y-intercept, the b value of 4. So I'm going to go up 4 on my graph and plot a point at that place. So hopefully you can see that purple dot right on top of that blue dot that was also included in the parabola. And then I'm going to use my slope to find other points. So negative 2 over 1, that means down 2 and right 1 would be one way to plot points. So do some that way, going down 2, right 1. So I just continued going down 2, right 1, all the way until I went off the graph. Down 2, right 1, down 2, right 1, and so on. And then I'm going to plot some in the other direction because I want to find the other place where this line crosses the parabola. So now I'm going to go up 2 and left 1, and then again continue that pattern until we run out of space or go off the graph. Then we can connect with a line using a ruler or a straight edge of some sort to make sure that this line is straight. Okay, now one very important thing that I'm missing on my graph is labels. As soon as I graphed two things, I need to make sure that I throw labels on there so I know which one is which. So I'm writing just that y equals negative 2x plus 4, and that's going to go on the line, and then I'm also going to label the parabola. So up at the top, I'm just putting that y equals, and then the x squared plus 4x plus 4. And remember, that's very important whenever you have more than one thing being graphed because I need to know which is which. Okay, now I have done all this lovely work and I don't have an answer. And there's really a problem with my graph because when I graphed these two, I could see that there's one point of intersection here. But when I look to this part over here, I can see that the parabola is continuing and the line is continuing. So mine graph does not show where they intersect for the second time. So I really had two options. I could have adjusted my scale and made these worth 2 and then change both graphs. But since we just went over a way to use the calculator to find the intersection, I'm going to do that. So hopefully you have the parabola in y equals. If not, just put that back into y1. And then in y2, you're going to put y equals the negative 2x plus 4. And then we're going to follow those instructions that were on the previous page. So once you have both in y equals, you're going to take a look at the graph. So you can just hit the graph button to look at it. I can see on that graph that similar to what I have here, they intersect, but I can only see the one place on my graph. So we're going to hit second trace and then scroll down to number 5. So the second trace, that's because that's calculating. And then either scroll down or press the number 5 to select intersection. I'm trying to calculate the intersection. Then you need to move the cursor, the little thing that's flashing, close to the intersection. So as close as you can, move it over and then hit enter 3 times. It's going to ask you to guess in that, but we just say, okay, it's close to over here. Let's just calculate it. So enter 3 times. Then your calculator will give you the answer. So hopefully when you've done all that, and hopefully you practice it along with me, you find that the solution is negative 616. Now you could do it again in the calculator, second trace number 5 and move closer to the other intersection, or you can read it off of this graph and see that it's at 0, 4. Another place to look and check is to go to the table of values, and then you can find the points for the solution on there because they would match on both of the graphs. So those are all options to find the solutions. Hopefully you were able to use one of them to find negative 616. That was the hard one there. And the whole point of that was just so I could go over the steps in the calculator in case you do all this work and it ends up being a point that doesn't show on your graph. Okay, let's try the next one. Okay, number 3 here says if f of x equals x squared minus 2x minus 8 and g of x equals 1/4 x minus 1, which values of x? So that's important. I'm going to highlight that. We only care about the values of x, where f of x equals g of x. That means the x values when the y values are the same. So since this is a multiple choice answer, I'm going to either put these in y equals, so we would just put y equals x squared minus 2x minus 8, and then y equals 1/4 x minus 1, and then we can look at the table of values or calculate the intersection. So the steps to calculate it in the calculator are on the previous page, where you would just go to second trace to calculate number 5, move close to where they're intersecting, and then hit enter 3 times. And that'll spit out the answer for you. But we can also look at the table. And the reason I do that is so that in case you forget the buttons to find that intersection, you can still use something that you've done regularly in class, looking at tables, to find the answer. So when we look at the table, I'm going to specifically look for the options that are here. Now, these are decimals, so I'm not going to start there. I'm going to start with, 0. Let's see if an x value of 0 matches for both. So when I go to an x value of 0, I see that the parabola is at a negative 8, and when I look at the line, it's at a negative 1. So those don't match. So hopefully you see that on your calculator, and I'll write down the table so you can reference it. Hopefully the one that you looked at matched here. So I have my blue, that's my f of x, or the parabola here. Those are my values I got from the table. I started at a negative 2 because it was smaller than the first one here. And then went to a value of 4 because that was the highest x value in my multiple choice answers here. So hopefully your tables match what I have here for the parabola, and then the linear function, here's my y values that I got. So again, when I look at those answers, I already eliminated choice 2 because the x value of 0 did not match. That means I can also eliminate choice 4 because, again, the x value of 0 didn't match. When I look at my table over here, an x value of 0 is -8 here, and 0 here is -1. So at that x value, the y's are not equal. Now I got to look, okay, well, this one is 2 decimals. So let's start with this one, -1.75. Well, I don't really know about that, but let's look at the x value of 4. If I look at 4, oh, look, it's 0, and it's 0 here. So I know that's definitely one of the solutions. So I don't even have to worry about the other option. I know that it's choice 3. This must be the other place where they intersect. Okay, let's look at another one, number 4. If h of x equals 2x minus 15, w of x equals x squared minus 6x, which pair below makes h of x equal to w of x? So I'm going to do the same method. You can calculate it in the calculator if you would like, using the steps on the previous page, or find those tables and look at the values. I'm going to start by looking at those tables of values. So they're just looking for a point. One of the points are the solutions. So that would make the y values equal to each other. So I chose this table because when I look at the x values, I see a 0, a 3, a 5, and a 6 as the 4 options. So I just started at my table and started looking down till I found one that intersected. And I can see here that this 3, -9 appeared on both. So that's why I chose this part of the table to graph. I can see that I found my solution, and then I just wrote down what I was looking at on my table. You could also scroll down in your calculator if you'd like to show the specific x values that are in the option, the 5 and 6 as well, if I move down on the table. But I just stopped because I found the intersection. It was at 3, -9. That appeared on both. So my answer is choice number 4. Now, one last thing you could have done was to plug in the x values into the equations to see if the outputs matched. Okay, that's it for this video. Have a good day or evening.